Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about looking at a top-down mooring design and analysis. So what do I mean by that? I mean, sometimes moorings are deployed, for example, from an ice shelf hanging down in the water column, rather than from an anchor with the mooring floating up in the water column. And it's not very common, and ProteusDS is not exactly designed to work this way, but I wanted to show how you could go about doing an analysis like this. So I'm just looking at ProteusDS Oceanographic Designer here, so we'll just start a brand new project, and maybe we'll pick subsurface mooring, because I guess it will be that, but you have to think kind of, for lack of a better word, upside down. So now normally when you're working in Oceanographic Designer, everything is kind of configured, from the anchor at the bottom going up to where the buoy is, whether it's surface buoy, surface mooring, surface buoy, or subsurface buoy, the top buoy and the mooring here. So you have to kind of decide how you want to go about interpreting what's in here. Do you want your top buoy? Now you can't have this floating thing on here because it's held up by the surface where the ice is. You need stuff hanging down from it. It's got to be heavy in the water, and these will obviously float up back to the surface. So we actually have to delete the buoy from this. And we'll need something heavy on it. Now, wire is heavy. This will float on its own. We might want to add something heavy on here, or maybe we use the anchor point here. So it doesn't really matter. You can choose whichever way you want to do it, but just know that you'll have to make a manual change in the analysis later. So I think what we'll do is we'll say the anchor is what we're going to fix on the water surface, the ice surface, if you will, and then just let the rest of the mooring kind of fall down in the water column. So we'll call this, instead of top buoy, depressor weight. So this would be the free hanging end of the mooring down in the water, and then you could have stuff kind of have instruments and things, like maybe we'll put a little CTD, a seabird, microcat, just partway down on this little line here. So we don't have any depressor weight here. Just for the sake of expediency here, I will add a hefty shackle, on the end. That looks like the biggest one we've got there, just to give it a little bit extra weight, although the wire is heavy as well. So we'll save this. I'm just going to save it here, top-down mooring. Now we have a default current profile here with some flow on the surface. I'm just going to leave that. I'm not going to change anything here. And what we'll do is we'll go to Static, Export. Now here's where you have to do some manual changes. Now it's made the ProteusDS Simulation Toolbox files for us here to do the analysis. You got to do a little bit of changing though. So here's our little preview, looking at the visualizer button here. We're looking at our world, and obviously, for normal subsurface mooring design, it's going to put the anchor on the seabed, and here's our mooring. But we want to do things the other way around, top down. So what we can do is we keep node n static 1. That is where the anchor nominally is. It's pinned down here on the seabed, so it's not going to move. We want to pin this at the water surface. So we leave this node n static. That's node n there on the mooring. And we manually change this by going, making sure we're clicked on mooring here, and we go to state. And this is what uniquely defines the all of the nodes used in the mesh modeling the mooring here. So we'll click on edit at the top here and just click on yes here. And then what we want to do, we don't want to change the length, but we do want to have node 0 at the water surface. So right now it says the Z is 250 meters. In other words, 0 above the seabed. Remember, we had a seabed of 250 meters water depth. So if we change this to 0, it's going to move the node up to the surface. You see it's sort of flipping things around here. It doesn't matter what the initial, the other end of the line is. It can be sort of bunched up on it itself a little bit. That doesn't really matter. We'll let the ProteusDS calculate where it's supposed to go. So as long as it's not all bunched up in one spot, I think we're okay. So we just go OK, and we don't have to change anything else. So we'll just go Apply, and now you see the anchors sort of flipped up at the top. That is still going to be fixed in space here. Now, I'm glad we don't have a big float here, because otherwise that would float up. The physics would calculate with the float pushing up to the surface, but we do have our little, Crosby anchor shackle here. It's pretty high current, so it might kind of get pushed up quite a lot. Well, I guess we'll just see. And otherwise, well, we just run it. So we'll go run and let it do its calculations. So this might just take a moment. Okay, that's just taken a little bit of time to simulate, and it's all done. Just a couple of minutes. Let's take a look at it. We'll open it up in PostPDS here. So we have it in orthographic view. So here's our world. Where's our mooring? There it is. A little hard to see, so I generally like to go to engineering view here. There it is, hanging down, and we'll go to orthographic view. Check it out from the east. And so first we have the input, so it's just hanging down. We have the stretched profile. There's not a lot of tension here, so and then we got our deflected form. So it's a pretty high current profile, and really just got a jackal and wire rope hanging off here. So of course it's going to lean over a lot. But yeah, mainly what I wanted to do is just highlight a workflow you could do to look at this from hanging down from the surface, and what that would look like. All right, well, thanks for watching.